Good afternoon. Please sit. Give me one question paper. Question paper. Okay. So now paper discussion. Tell me if you have any doubts. 6. See, question number 6 here. A current loop having two circular arcs joined by two radial lines as shown in the figure. It carries a current of 10 ampere. The magnetic field at point O will be close to how much is asked. Is the arc shaped wire. The point O, and this is also this length equal to here 2 centimeters, and the angle subtended here 45 degree, and the total current flowing in the each turn, each segment is 10 ampere. This distance also given, that is 3 centimeter. So we have to find the net magnetic field at point O. Tell me here how many segments are there. This is the first segment and second segment and third segment and next what? Fourth segment. Understood? So net magnetic field at O I can write B1 plus B2 plus B3 plus B4. Is there any magnetic field due to this straight segment at point O? I'm asking you. No, why? Which books? The 11th you will receive 4 volumes, 12th you will receive only 3 volumes. All chapters are there in the 12th. Yeah, you just write what chapters are missing in one paper. I will look into that. Physics alone, 12th volume, three volumes are enough. It covered all chapters. Any chapters are missing in 12th? I verified in 3 volumes of 12th standard, all chapters are covered. And the remaining 3 subjects, what chapters are missing, right? So I will decide whether you will receive volume 4 or not. Understood? Now, is there any magnetic field to first segment? No, and there is no magnetic field to third segment also. Why? Because the point O residing on the same segment, they do not contribute any magnetic field. So who will contribute magnetic field? Only the fourth segment and second segment only will produce the magnetic field. What a magnetic field to second segment? First direction. Keep your thumb in the direction of current and bring the fingers, curled fingers at O. They are going inside the board or paper. So put minus. What a magnetic field to arc shaped wire formula? Very good. Mu naught by 4 pi into I by radius. For this arc shape is concerned, what radius? 3 plus 2, 5 centimeter, na? Correct or not? So 5 into 10 power minus 2 meter. What is the current flowing? 10 ampere and into angle of the arc. What is the angle of the arc equal to? 45. 45 means should convert into radian. That is the total magnetic field to second segment. Next, what of magnetic field to fourth segment? Compulsory plus you have to write. Why? Keep your thumb in the direction of the current. Magnetic curl fingers are coming outside the board. So compulsory have to keep the plus symbol. So how much that is? Mu naught by 4 pi into current 10 divided by what is the radius? 3 into 10 power minus 2 into how much? 5 by 4. 5 pi cancels out. Understood? Mu naught value how much here? Mu naught value how much? 4 pi into 10 power minus 7. So 4 pi cancels out. Here also how much? 10 power minus 7. And if you simplify further, 10 power minus 7 plus 1 will come here. And the plus 2 will come upside. So 3 minus 7 means what? 10 power minus 4. 1 by 20 means what? 0.05. Correct? 0.05 means what? 5 into 10 power minus 2. Here how much? 1 by 12 means? How much that is? Minus 5 into 5 into how much? 10 power minus 6 and plus 1 by 12. So here 1 by 4 will come and 5 also will come and how much? 1 by 3 into 10 power minus 7 plus 1 and plus 2. Here also what will happen? 10 power minus 4 will come and 1 by 12. As per the option, decimal you have to convert. Huh? Yeah, 1 by 3 0.33. 4 ones are and 4 zeros are, 4 zeros are, 4 eights are something. So here what will happen? 5 into 5 value how much here? 3.14 into 10 power minus 6 plus 8. Yeah, 8 by 100 and into how much? 3 into 10 power minus 4. Even in the options, big difference only there. So if you simplify further, what you can write? Say 8 3s are 24, 5 3s are how much? Minus 15 into 10 power minus 6 plus 24 into 10 power minus 6. 24 minus 15, how much? 24 minus 15 means approximate only. 10 power minus 6 will come. And 10 power minus 7, if you convert, what will happen here? 90 into 10 power minus 7. So 10 power minus 7, everything is wrong answer. What is the answer? Option A, that one I am saying. I converted into 10 power minus 7. Na? So 10 power minus 7, option C wrong, option B also wrong. Now we have to convert into 10 power minus 6. So what I can write? 9 into 10 power minus 6 into 10. I will multiply and 10 I will divide. So 0.9 into 10 power minus 5. Anyway, approximation all I have done now. 0.9 is very close to 1 into 10 power minus 5 decimal. Next. Seventh. Question number 7. Two identical wires A and B of length capital L and each carrying how much current? I amperes of current is flowing. Wire A is bent into circle of radius capital R. The wire A of radius how much? Capital R. And wire B is bent to form a square of side how much? A meters. This is the length A and length A. This is also how much? Length A. Each of A meter. And the magnetic field of this wire A and magnetic field of wire B at their centers of the circle and square respectively. You people tell me what is the ratio of BA by BB? Respond. What is the magnetic field to entire circle at the center? Very good. Mu naught into capital I by 2 into capital R and whole divided by, and what is the magnetic field to this finite wire? For example, every wire is finite wire. This finite wire will produce magnetic field is out of the screen. If you have doubt, keep your thumb in the direction of the current. Bring the curled fingers at center, they are coming out. So, like that, 4 wires are producing magnetic fields coming out of the screen only. So, I can write 4 into magnetic field to each finite segment. Tell me someone, what a magnetic field to each finite segment? Mu naught by how much? 4 pi and into I divided by perpendicular distance. What is perpendicular distance? A by 2. 2 will go to numerator and these edges are making how much angle here? 45 and 45. Understood? Correct or not? So what I can write here? Sine 45 plus sine 45. Correct or not? So mu naught is getting cancelled out and 4 getting cancelled out. So what I can write here? I by 2 into R and whole divided by how much? How much here? 2 into I into bracket start. Sine 45 plus sine 45 how much? 2 by root 2 and whole divided by how much? Pi into A. Understood? You know the length of each and every wire is capital L is given. So L equal to how much? 2 pi into capital R equal to circumference. So capital R value how much I can write? L by 2 pi I can write. In the place of capital R, L by 2 pi I can write. I also cancels And what is the length of this wire also? Capital L. L equal to how much? A plus, A plus, A plus. 4A. So L equal to how much here? 4 into A. So A value how much here? L by 4 here. Now here L, this L cancels. This two cancels. How much this is? 5 by 2 and whole divided by how much? 8. 5 by 4. You can't write. So pi root 2 will go upside. Pi square root 2 divided by how much? 16. So which is the right option? Option A is wrong. Option C is also wrong. Option D you have to convert. Option D, denominator root 2 is there na? So I will multiply with root 2 and I will divide with root 2. Root 2 into root 2, what will happen? It will happen 2 and 2 ones are how much? 2 8s are. So option 4 is the correct answer. Next. 8th. Question number 8, everyone. Some current I is equal to 2 ampere is flowing in a wire frame as shown in the figure. How much current is flowing here? 2 amperes of current is flowing as shown in the figure. The frame is a combination of two equilateral triangles ACD and CDE of side 1 meter. Okay. What is the length of each side? ACD is given 1 meter and C and D and E length also given 1 meter. And the magnetic field equal to how many Tesla? 4 Tesla. Acting perpendicular to the plane of the frame. The magnetic force acting on the frame is how much? Who said total length? Okay, sorry. ACD is triangle. She is correct. I was mistaken. Correct one. Length of the each side is 1 meter and what is the magnetic force acting on the each frame? One diagram also given. This is one triangular frame. This is also another triangular frame. Where the magnetic field is going? Into the screen it is going. As per the data, all sides are equal. This is triangle ACD and this is a E triangle and here current is flowing like this, here current is flowing like this, here also current is flowing like this. Okay, so total magnetic force acting on the entire system we have to calculate. I will remove these two wires and I can replace with the single effective wire from C to D. Do you have any objection? Again, these two wires also I will remove and I will replace with the effective wire of length how many meters? Same 1 meter. I will the concept of effective length. Whatever wire is there. For example, if this wire is there means only you have to take the shortest distance between the two tips. That is the concept of integration. Magnetic force on the each segment how much? Integration of I into L cross B means integration meaning from shortest distance between this tip to that tip. Understood? Now find magnetic force on each and every wire. What a magnetic force formula? I into effective length vector cross B vector. So L to B, length vector is right side na, L cross B. So every wire will experience a magnetic force upside only, na? Please say yes or no. So the every wire will experience magnetic force upside, but a net magnetic force equal to how much? 3 into F. Means what a magnetic force acting on the each wire? How much? I into L into D into how much? Sine of 90. So 3 into what is the total current? 2 ampere and length equal to how much? 1 meter and magnetic field equal to 4 and 24 Newton is your answer. Is it clear? Next. Here additional information everyone. What is the magnetic force on this semicircular wire? For example, this is 1 ampere. Radius is 1 meter. It is placed in 1 micro Tesla going into paper. What is the total magnetic force on the wire? For that, you have to do integration. Integration in the sense, instead of this curved wire, straight wire you can take. Yes or no? Correct or no? Understood. What is the magnetic force acting on this wire? I into L into B into sine 90 means angle between L and B is 90 degree. I value how much? 1 ampere. Length is 2 meter. Magnetic field is what? 10 power minus 6 and into 1. So that is how much? 2 into 10 power minus 6 Newton. Is it clear? Okay. Next. Length radius is 1 plus 1, na? Shortest distance 1 plus 1. 1 plus 1, 2 meter. Okay. Eleven. Fake.
Yes, sir. They didn't say no, sir. Registration number. You told it out. It will open it on April 2 days.
It is fake. July 17th also fake.
Yes, sir. Everything was fake, sir. You posted me, sir.
Means it is April Fool, huh?
Yes, sir.
Oh.
Yes, sir. On April 10th,
You are not a fool, huh? You are intelligent, huh? You are Einstein, huh? Everyone is a fool only. Understood, huh? You are a fool like that you are saying? Tell me. So then who fooled?
Nine show.
Who fooled you?
You fooled us, sir.
That also not understood. Okay. Okay. So next question. Next question, please. Not yet announced official. Same July 17th, July midweek. Okay. Next question. So 11th question. A square loop is carrying which current? I amperes of current. And the magnitude of please. That notification not yet released. Understood. Somebody posted to me. I thought it is realized. I don't know how that fellow. No, yeah. Actually, my side also one academicians group is there. That is some South Indian. Then he told me notification. He called and told me it will happen. Even yesterday, a few students called me, sir. When I mean the window will be open, we have to apply. I said April 5th. Today only started your office. I think not released, huh? Okay. See, trust is a matter. Okay. Next question number 11. So a square loop, over that notification not released. But I am predicting that definitely July mid-month or ending, definitely will have neat exam. Clear up. Okay. Leave that. And one more thing, please write Super China test also. How is the paper, ma? Good or not? I told first 15 students compulsory should write means many students not written. That is our interest towards neat person road. Boys, where is that person? Kavi except to all boys. Then personally also I message. That is our interest. Okay. Anyway, waste of time. You will not change. So a square loop is carrying a steady current how much? I ampere. And the magnitude of the dipole moment how much? Capital M. And if this square loop is changed to a circular loop and it carries the same current and magnitude of the dipole moment of the circular loop how much? Okay, students. So I will assume as per the data, what the length of the each side? Please respond. What the length of the each side? I will assume small a meters. And now tell me what is the magnitude of this square loop moment? What the moment of this loop? How much? I into area. What area equal to? Small a square. Next as per the data, we converted into which wire? Circular shape wire. Means I will assume the radius is small r. Tell me what is the new magnetic moment of this circular loop? I into pi r square. I will divide them each other. I cancels out. So what will happen? M prime by capital M equal to how much? Pi r square by how much? A square. Understood? So what is R value here? What is small r value? Shall I write this length of this wire? This length of the wire same. What length of this wire? 4 into A. What length of this wire? Very good. 2 pi small r. So in the place of small r, I can substitute how much? 2A divided by pi I can write. So substitute here. So you will get a new magnetic moment equal to how much? M into pi by A square into pi r value how much here? Very good. 4A square by pi square and A square pi by cancels out. So 4M by pi. Option A is the right answer. Okay. Next. Bias this time how many marks? You have to give response quickly. After 1 year, you are giving response quickly. How many marks? How dare you to say that? Immediately after 10 minutes of exam over, you have to count. Once key received, you have to count. That is our responsibility. That is our interest. Sit. 70. Harshit, for you 530 or 540? 500. Oh, first. You did a fantastic job. You Atari, question number correctly wrote. Okay. What question?
17.
70. See, question number 17. A uniform magnetic field of how many Tesla? B is equal to how much? 1.5 Tesla exists in a cylindrical region of radius how much? 10 centimeter means 10 into 10 power minus 2 meter. Its direction is parallel to the axis along east to west. So this is one. Assume this is the board as a surface of the Earth planet. How many directions are there? East, west, this is north and south. So there is one cylindrical region containing magnetic field in which direction from? Containing direction from where to where? East to west. Sorry, this is east to west direction. Magnetic field is there along the x-axis. I mean principal axis of that wire. Now a wire carrying current 7 ampere in the north to south direction passes through this region. One wire is acting from where to where? North to south. One wire is there. How much current is flowing? 7 amperes current is flowing from north to south direction, passes through the region. Then what is the magnitude and direction of the force on the wire? If the wire intersect the axis. Here three questions are there. First question is A. What is the wire intersect the axis? What is the net magnetic force on the wire is asking. What is magnetic force acting on the wire formula? Current into length into magnetic field. Wire length is given. Magnitude of the direction of the force acting on the wire. Okay, so here I think length of the wire in the sense you have to understand inside the cylindrical region it is there. So indirectly he has given the length equal to diameter of the cylinder. So what is the diameter of this wire? Sorry, diameter of the cylinder equal to length means what? 20 into 10 raised to minus 2. So current is given 7 ampere. Length is given 20 into 10 power minus 2. Magnetic field is given how much? 1.5. How much this is? 2.1. Sorry. 2 ones are 2 1.5 are 3. 3 sevens are how much? 21 into 10 power minus 1 means 2.1 Newton. So 2.1 Newton is confirmed and you have to find the direction of the magnetic force. Tell me in which direction the magnetic force will act? L vector to B vector. What is L? L is acting downwards. L to B. So the magnetic force on the wire acting wire locking. Direction we have to lock. We are living in some world. But this small things only are laughing. Then I can understand your state of mind. This L cross B na. This L towards B. In which side? Upside or downside? Downside, right? L and towards B. So into the paper. Into the paper means so inside means downward only is meaning downward only, not upside. Anyway, option B is 100% wrong. One option we deleted, and remaining options also we have to verify. B I am removing, so we have to verify option B. Some more details we'll get. Now the wire turned from north to south to north to east. Instead of north to south, in which direction it is there? This is the direction of the magnetic field. In which direction it is tilted? From north to east, like this. Yes or no? Means like this. North to east it is tilted. Okay. So tell me, what is the magnetic force acting on the wire? Again, this wire has how many components? This is 20 and this is 45. So this is 20 sine 45. Na? Understood? This wire I am splitting into two components. One is X component and other one is Y component. So only it will experience a magnetic force acting on this direction. On this perpendicular component only. Here I am giving some important statement. Please concentrate. This wire, how I am splitting into X component and Y component. Is there any magnetic force acting on the X component wire? No. Why? L and B angle is 180. So L into B into I into sine 180 is 0 only. Na? So there is no magnetic force acting on the component. Only on this component only magnetic force will be acting. So what a magnetic force acting on that? I into L into B. Current is how much? 7 ampere. What is the length of this wire? 20 sine 45. Na? 20 centimeter to sine 45. That's how much? 20 into 10 power minus 2 into sine 45 means what? Root 2 into magnetic field is given how much? 1.5 Tesla. In which direction it is acting? Magnetic force I am saying. But a magnetic force L towards B. Again downward only. There downwards, here also downwards now. So with this hint, I can delete option D also wrong. Why? Option D, if you see, one is downward, one is upward, na? But both should be in the same direction. 2.1 and second force also both should be in the same direction only. Na? 100% C is wrong. Why? Sorry, 100% A is wrong. Why A is wrong?
A is opposite direction. Both are in same direction, sir. A.
No, ma.
The direction same only, no, sir.
No. Wait a second. Actually, I did a north south to northeast, the north to west direction. Option B. Did you understand the meaning of the option B? The wire turned from north to south to north to east. To stop north to west. Okay, anyway, if it is tilted to north to east or north to west, same result will get. If the wire is tilted to north to east or north to west, only the perpendicular component only you have to take. Actually, R should be printed, but R is not printed. I can sense that. So both will get the same answer only. But what is the direction of the magnetic force here? L and towards B. Means this is also downward. So definitely
A or C.
both are downward means C is only the correct answer. Why? Because very simple logic. Here only L is there and here L by root 2 is there. Root 2 will decrease 2.1. Na? So C is only the right answer.
A is yes.
He is A. Na? He is A is wrong. Surely it is wrong. Take this. Yes, A is wrong only.
The radius given as a
Huh?
radius given.
Radius. Indirectly it is given length. Length of the wire is given. Next it is tilted to like this 20 root. Yes. That wire should be inside the wire, inside the cylinder only, na? This is 20 centimeter wire. This it is tilted to north to east or north to west, no? If it is tilted to north to east means north to east. This is north to east. It will be like this. That is 20 centimeter. Then still also you have to take the length 20 by root 2 only. Key mistake is there, students. If key is given A means definitely wrong. Why? Because here 20 into 10 power minus 2 is there, but here you should take sin 45 component. Divide by root 2 only should come. So not A.
1.48 is
Where?
you divide this way. And the calculation 1.48 is.
Are you sure? Huh? Do it with calculator. Then total question is wrong.
Yes.
Anyway, option C I will verify. Option question number B itself. Hello, question number B itself. Some question is not clear. North to east he has taken a, north to west he has taken a. That is a dilemma and the problem. Anyway, key is given wrong. Anyway, option C I will verify. The wire in the north to south direction is lowered from the axis by a distance of 6 centimeters. Then the total magnetic force is asking. Total magnetic force. It will not change, na? If it is lowered also, it is immersed, just lowered, but direction did not change. Means I will not change, length will not change, magnetic field also will not change, same 2.1 Newton will come. Understood? So in this aspect, option A is wrong, definitely. So nearest also, if you take option C is only the correct answer. Option C is 75% probability is there. Why? Because C is correct and A is correct and C is correct. Understood? We are not getting accurate answer even though we are taking sin 45. Definitely it is a objectable question. Next question. Someone please write in the page question number 17. Answer question itself wrong. Next 22. Question number what, right? 22. Question number 22. A closed loop PQRS carrying current is placed in the uniform magnetic field. If the magnetic forces on the segments PS and SR and RQ are F1 vector and F2 vector and F3 vector respectively, and are in the plane of the paper along the direction as shown in the figure, then what is the magnetic force acting on the wire QP? Okay, so in the plane of the paper, that loop is in the state of rest. So definitely here the loop should be in the state of rest. Means this is acting F1 vector here. This is acting F3 vector here. On this segment, F2 vector acting like this. And the fourth force, which is acting on the segment number PQ, should nullify this resultant of the three forces. Then only the loop will be in the equilibrium. Tell me what is the net force of this one? Definitely F3 should be bigger, no? Why F3 should be bigger? Once please check and tell F3 is bigger or not. Why? Because magnetic force acting on the segment equal to I into L vector cross B vector. So the QR segment is bigger. So with that confidence I am telling F3 is bigger than F1 vector. I do not care this F2. Why? Because it may be equal or the sides ratio it did not give. What net force of this F1 and F3? What net force and F1 and F3? F3 vector minus F1 vector, and this is the F2 is there. And according to parallelogram law vector addition, construct one parallelogram. The diagonal is representing what here? Net force of these two forces. But net force equal to under root of how much? F3 minus F1 whole square plus F2 square. Then the fourth force acting on that slant segment should be nullified this one. Then only the loop will be in the equilibrium. In any loop, net force should be zero. No? If you take any loop in the magnetic field, this force is nullified by this force is nullified by this force. So this rule you have to remember. Any closed loop that you kept in the uniform magnetic field, it should be in the equilibrium. The reason is net force should be zero. So what a net magnetic force formula here and the fourth segment. This is your answer. Which is the right option? A wrong, B wrong. C is only the right answer for the question. Clear? Next. 20. See, question number 20. In a mass spectrometer used for measuring masses of the ions, and the ions are initially accelerated by an electric potential capital V, and then made to describe semicircular path of radius how much? Small r, and using a magnetic field how much? Capital B. And if V and B are kept constant in the ratio, okay, V and B, I mean velocity by magnetic field kept constant in the ratio, kept constant. Then the ratio of the charge by mass, is proportional to R. Is expecting R relation. R 1 by R 1 by r square, like that is asking. You know what a radius of the circular path or semicircular path formula? R equal to mv divided by q into b. Understood? So he said b by v. What is actually v and b? V and b are constant means. Students, here b means, please do not understand velocity, potential drop. Understood? So I can write r is equal to momentum. Momentum in terms of kinetic energy, how much? Under root of 2m into kinetic energy of that particle. Everyone knows or? Knows or don't know? No. Should remember momentum equal to under root of 2m into k. And what is the kinetic energy acquired by the charge? Very good. Q into potential drop across that cathode and anode. And now we have to find capital V by B as a constant. We have to use, and is asking relation of the radius. We want Q by M as a subject. So R, anyway, you have to keep it this side, and R is equal to what I can write? Root Q M I will write a side, under root of M into Q divided by Q, and root 2 into V by magnetic field I will write a side. Then what I can write here? Under root of Q square I can write now. Small q in the denominator I can write, under root of Q square I can write now. Then Q by Q square means what? Q will go and this square will cancels out. So we have to find the Q by M ratio only na. I will do the squaring on both sides. So what I can write? R square equal to M by small q into 2 into V by B square. So Q by M, what I can write here? Q by M, if you write as a subject, 2 into V by R square into B square I can write. No. Wait. He's asking V and V are kept constant in the ratio. I mean anything V and V constant, not ratio. Then V constant, 2 constant, V constant. So what a Q by M is proportional to R square and inversely proportional to R square, proportional to 1 by R square. Which is the right option? C is the right answer. Key correct? Next. Question number 25. This thing we already discussed in the problem. The class during the lecture we discussed now. Still you want this is directly during my lecture I explained. If you still you have doubt, because doing one time only boring, doing second time means it's a waste of time. Ask another question. 33. Question number 33. A particle with a charge how much? Capital Q, and moving with a momentum capital P and enters a uniform magnetic field normally, and magnetic field has magnitude capital D and confined to a region with a width how much? Small d, where d is less than P by B into Q. then the particle deflected by an angle theta in the crossing field. I gave one formula. Someone please give me the deflection of any particle in the magnetic field. Sin theta equal to small d divided by r. I gave this formula deflection. Once you refer, theta equal to how much? Sin inverse of radius of the circular path by, width of the magnetic field by radius I have given. What radius of the circular path? mv by q into b. I told to memorize also, you can save a lot of time. mv is nothing but what here? Momentum p. Understood? So based on this, you have to give the answer. This is the right option. Sin theta equal to bqd divided by p. So option A is only the right answer. Understood? Or else you want me to revise the concept again? Is any uniform magnetic field? This charge is entering into the magnetic field and it is deflecting like this. It will go like this. It is following a circular trajectory. You drop one perpendicular line. You drop one perpendicular line. Where they are meeting equal to center of the circle. This radius equal to capital R. This radius equal to capital R. This angle is only deflection. This width of the magnetic field is small d. So sin of t, what I can write? Opposite side by hypotenuse I can write. So you can write sin of t equal to how much? Opposite side or width of the magnetic field by radius. This thing you have to remember, radius of the circular path. You know very well, that is mv by. Next. Okay, now everyone take a 10 minutes break. After 10 minutes also I will continue. Okay. Botany sir is on leave, I will take. Or else will you study? What do you study? Botany will study. Okay. Thank you.